Here's another question from the website wamap.org, part of their pre-calculus material. And so for each angle below, we're supposed to determine the quadrant in which the terminal side of the angle is found and find the corresponding reference angle theta. So in our coordinate system where we add an angle, let's sketch that out real quick. We'll get us a coordinate system. Let's move it down over this way instead. Uh, we're gonna have a circle in there. Let's draw us a circle. And well, the circle is just sort of a reference. Do I need the circle? Nah, let's do it without the circle. Okay, and so we're trying to figure out where these quadrants is. Well, the standard angle in the coordinate system is 0 degrees and 0 pi is at 0, or 0 radians is at 0. In looks like a lot of these are in radians, so let's do pi over 2 is on the positive y-axis. The negative x-axis is pi, an angle of pi, and 3 pi over 2 ends up down there at the bottom at the 270 degrees, or along the negative y-axis, going from the origin down the negative y-axis. So 5 pi over 3. Well, 5 pi over 3, I want to go up or down to get something nice. Well, if I add pi over 3 to that, I'll add 6 pi over 3. If I add 5/3, if you add 1/3, you get 6/3, which is really 2. And so 2 is going to take you all the way around. 5 pi over 3, 5/3 is actually a little bit more than 1.5. 3 pi over 2 is 1.5. So 5 pi over 3 is going to end up down here in the fourth quadrant. And we're looking for the reference angle, and the reference angle is always the angle going back to the x-axis. So if I've gone 5 pi over 3, how much farther do I have to go to get back to the x-axis? Well, I know it's 2 pi all the way around, so if I take 2 pi and subtract 5 pi over 3, I'm missing a pi over 3. That'll give me 6 pi over 3. So I am in quadrant 1, 2, 3, 4. Uh, Womap wants you to actually enter the number 4 and not the Roman numeral 4. It says that in the instructions that I did not copy down. And then the angle that we want is pi divided by 3 for our reference angle. 5 pi over 4, that's 5 pi over 4 is a pi over 4 more than pi. So 5 pi over 4 actually ends up here in the third quadrant. It's like a 45-degree angle that you're looking at for 5 pi over 4. And the angle then going back to the x-axis, the reference angle would be that angle in there. And I know it's 5 pi over 4 there, so if I want to go back to pi, 5 pi minus 1 pi over 4 ends you back to that one, and that ends us in the third quadrant. 5 pi over 6, that's a little bit shorter than 6 pi over 6. 6 pi over 6 would be just pi. So 5 pi over 6 ends us up in quadrant number 2. And our reference angle, if I, that's getting kind of busy now. Let me kind of erase some of that stuff. Oh, got the angle. All right, erase too much. Let's draw back in our axes. And then I'll reposition them so they're in the right spot. Oops, give me that. There we are. Reposition it in the right spot. Uh, would be there. 5 pi over 6 should end up in quadrant 2. And then the angle, again, we're looking at the angle. How big of an angle is it back to the x-axis? Well, that's going to be a difference of pi over 6. If you have 5 pi over 6 and add another pi over 6, you'll get back to the x-axis in there, back to the x-axis in there. 7. Oh, theta is equal to 7 radians. Well, 7 radians. I guess we need to know a little bit about the absolute size there, because we don't have the pi to work with. But I know that pi is about 3.14, and so this would be, in terms of a number, it's about 3.14. Half of 3 is 1.5. And so pi over 2 is about 1.5, and it turns out to be 7, because you take half of 14 at 7. If you do 3 pi over 4 plus, if you do pi plus a half pi, you'll get 3 pi over 2. So that will give us 4.6, 4.71, about 4.71 there. And then 2 pi is about double pi. And so if you go all the way around, that's about 6.28 if you go all the way around. But I'm going around 6.28 plus a little bit more. I'm going to end up over here at 7 radians. And so I'm going to end up in quadrant 1. And the reference angle is going to be that angle. How far do I have to go back to get back to the x-axis? And this one's not quite as pretty as the other ones, but if I take 7 and then I just going back to the x-axis, so I need to subtract 2 pi. So it's 7 minus 2 pi to get to that reference angle in there. Not quite as pretty of an answer as the other ones, but that will be the reference angle. That's what you need to do to get back to the x-axis. That's what your reference angle is. The nice thing about angles that are written in radians, your reference angle is just, it doesn't matter how many pi's it is. If it's, 8 pi over 3, your reference angle is going to be pi over 3. As long as that denominator is 3 and you have the pi on the top, the denominator is 3, the reference angle is going to be pi over 3. As long as we've got a reduced fraction, it's got to, like I said, the fraction has to be reduced. You say 6 pi over 3, your reference angle is not pi over 3. But if you've reduced that fraction as far as you can, and the denominator worked out to be 3, your reference angle is pi over 3. If the denominator works down to a 4, your reference angle is pi over 4. That it's a 45-degree angle back to the x-axis, wherever you look at. So a super nice thing about working in radians, the reference angles are actually really easy to find in there. You don't, I mean, you want to think about what quadrant it's in, but even once you figure that out, well, even before you figure that out, you know that your reference angle is going to be, if it's a reduced fraction on the bottom is a 6, then I know that my reference angle is going to be pi over 6 in there. It's a pretty cool aspect about being in radians.